it the next technique for extraction. This is the special case, and also is the technology that we call it the green technology. That's why we call this technology should be used and it's okay, suitable for the bioprocess. That's why bioprocess. If we use the organic solvent, there are some the effect of chemical to the bioproduct, and also there are some toxic chemical or hazardous waste from the organic chemical. And also, if we use the aqueous to phase extraction, it's better than the organic solvent. That's like organic solvent because both phase include the water. And also the technique now that I will talk to is supercritical phase extraction. This is the technique that is suitable for the bioproduct or biomolecule, as I product molecule. First of all, what is the supercritical fluid? As if we recall the knowledge that you study in thermodynamics, that's right. Thermodynamics that we draw the temperature and pressure diagram. Commonly, we have three phases: solid, liquid, and gas phase. Right? Solid and liquid and gas phase. And also we call the point that most of solid, liquid, and gas. At this point, we call it triple point, something like this. The triple point. The critical point is the higher temperature and the higher pressure for that gas. We have some PC, TC, because it is the critical temperature, critical pressure. The fluid, as I already we call the supercritical fluid. Supercritical fluid. What is the advantage of the supercritical fluid? Because this can improve this dissolution property of the solvent. It's easy to dissolve, something like this. It's easy to, that's like this for the supercritical, that's like fluid down by the gas property. Is able to penetrate substance easily. Created that means dissolve in the substance, or the solubility is higher when compared to the liquid, when compared to the normal gas, something like this. This is the first advantage of the supercritical fluid. And also the density. Its density can be changed in continuous manner by changing the pressure. That's right. Okay, and also the supercritical fluid extraction is more powerful technique that we can use to remove the fouling component, something like oil and grease from the device, and also used for analytical application, something like this. These three examples of the application of supercritical fluid we use to separate and purification. We use to separate and purify the essential oil and medical component. We use it to remove the grease or the fouling material from the process equipment. That's when you as the engineer, as you work as engineer in the process, there are some lots of tube, lots of pipe, and also in tube, in pipe, there are some cold water, hot water, cold fluid, hot fluid. There are some the fouling. The fouling means chemical. That's like the chemical precipitate to the pipe, and also this can be obstructed the flow. That's like the flow. We can use the high temperature and high pressure fluid, such as supercritical fluid, like to remove this fouling. And also for the food and beverage processing or drinking industry, that's like we can use the technique to produce decaffeine. That's like decaf coffee or decaffeine coffee, alcohol-free beer that we wish to produce coffee with low caffeine. That's like low caffeine. Produce beer with low alcohol. That's like alcohol-free beer is not exactly beer, but it's low alcohol. That's like decaffeine coffee is not exactly no coffee, no caffeine, but it's low caffeine content. Is it the application? That's right, the application. And also when you increase the pressure of the supercritical fluid, and also you increase the solubility. That means the supercritical fluid can easily to penetrate in the solvent, in the solid or in the liquid that we would like to separate. This is very important of the supercritical fluid. That's why supercritical fluid extraction we can use for both for liquid, solid, and liquid extraction. That's why liquid supercritical fluid extraction. Wait a minute. Supercritical fluid can be used for both technique. Liquid supercritical fluid extraction or liquid supercritical and solid supercritical. If you use the liquid supercritical fluid extraction, that means you use the supercritical fluid to extract the solute from liquid mixture, the side from liquid mixture. If you use the solid supercritical fluid extraction, you use the supercritical fluid to remove solute in solid. This can be found in the volatile component in solid. That's volatile component in solid. And also for this case, we show the phase diagram. That's supercritical carbon dioxide and the supercritical fluid is ethanol and water. For this case, we would like to separate ethanol from the water ethanol mixture. And also we have the diagram to show three phase. That's why this is 100 ethanol, this one is water, this one is supercritical carbon dioxide. In this line is the true component, supercritical carbon dioxide, ethanol. This line is two component water and ethanol, for example. And this line is two component carbon dioxide and water. But the soul or the area inside the triangle, the mixture of three components, And the curve in this is the equilibrium. That's right, equilibrium of the three components, or the maximum ethanol can dissolve in water carbon dioxide, maximum carbon dioxide that can dissolve in water ethanol dioxide system. If you know this diagram, you can decide for the extraction. I will talk to the detail for it in the unit operation for that case. Okay, this is the equipment. That's right, the process, the simple process for remove ethanol. That's right, remove ethanol from water ethanol mixture by the supercritical fluid extraction. For this case, we have the mixture of ethanol and water feed to the extractor. This is the extractor. And also this mixture mixed with this is the supercritical carbon dioxide. This is the supercritical carbon dioxide. Supercritical carbon dioxide from this carbon dioxide. The carbon dioxide is flow through the compressor. The compressor will increase in pressure and temperature until with the critical temperature, critical pressure. That's right. And then you produce the supercritical full carbon dioxide. That is the carbon dioxide below the critical, that's right, below the critical condition. After enter the compressor will increase in pressure and also increase in temperature until with the TC and PC. You get fluid, that's right, supercritical fluid mixed with the water ethanol mixture. And then the separation occurs by density, the higher density flow at the bottom, that's right. And the lower density is out at the top. At the bottom, we call the raffinate phase. The raffinate phase most is water, that's right, most water, a little bit on ethanol and carbon dioxide. But the top phase is extract phase. Extracted the most is the ethanol and carbon dioxide. That's right, it will carbon dioxide. For this case, is the higher temperature, higher pressure. And then we can reduce the pressure and temperature by release valve, this valve, the expansion valve, that's right, to reduce the pressure, And then we will separate ethanol and carbon dioxide as below critical temperature. That's right, the carbon dioxide here is not the supercritical. heat the carbon dioxide at below or gas phase carbon dioxide. That's like gas phase carbon dioxide. Then you can separate carbon dioxide and ethanol. Yes. It's maybe by absorption, it's maybe by phase separation, that's like liquid and gas phase, something like this. And also you can recycle carbon dioxide, mix with the fresh carbon dioxide, and then feed to the compressor to produce supercritical carbon dioxide. This is the simple equipment for extraction. The technique for extraction is the same. I talk to you. That's right. Then we talk to you because we have 3 components: ethanol, water, and carbon dioxide. That's right. Ethanol and water mix together at the initial, and then carbon dioxide is add to this mixture. Ethanol refer to the supercritical carbon dioxide because the supercritical carbon dioxide is easy to dissolve ethanol. Then water, that's right. And water, and the ethanol is transferred to carbon dioxide, and then we can separate ethanol from water. Right. This is for the liquid supercritical carbon dioxide, and also we can modify this by the membrane. That's right, the membrane. We have the membrane. This is the feed to the tube. This is to the tube, and also we have the extract phase. Have some membrane like this, and supercritical fluid it flow in the side, and then the supercritical flow across the membrane and mix with the feed, and then also we have extraction. The advantage of the membrane that it is easy to separate the raffinate and extract phase. The extract phase that flow across the membrane, and also the apparatus is compact. That's like small equipment, and also interfacial area. Interfacial area means the area that the liquid supercritical fluid can contact. That's right, contact. This is very important for the extraction, like the contact area between the substance. Like it can help increase the separation. And another technique we call it solid supercritical fluid extraction. Solid supercritical fluid extraction. For this case, we give an example of the decaf coffee. Decaf coffee, that means separate caffeine from the coffee. Or for that case, we would like to produce low caffeine. That's right, to produce low caffeine. Okay, we have the coffee bean feed to the extractor. The same in the pivot. We enter the carbon dioxide to the compressor to increase pressure and temperature. When you increase pressure and temperature, you get the supercritical carbon dioxide. That's right, supercritical carbon dioxide, and mix with the caffeine bean, and then we get the raffinate is more like the the coffee. That's right, the coffee. And also for this case, at the top we get the separate caffeine. The caffeine will separate and flow out together with the supercritical carbon dioxide. And then if you reduce pressure, that's right, the pressure is below critical, temperature below critical, you get the gas carbon dioxide mixed with caffeine. And then you can separate gas, caffeine, and carbon dioxide. And then you recycle carbon dioxide again. And this is the simple function for that case. And this is the supercritical fluid extraction technique that I show you. It's for simple, and I will show you some equipment in the lecture note that I show you. Okay, wait a minute. Okay, and I give you the lecture note is there is more detail. So in this case, I give you some the detail. At this is some example of the flow chart for the supercritical. This is due to extract beta carotene. That's why we use the beta carotene from the bitter melon. Bitter melon. Also, we have some to carbon dioxide. We need the carbon dioxide in gas phase. Carbon dioxide in gas phase. They have some the heat exchanger. That's not heat exchanger to increase the temperature. And also we have the high pressure heat exchanger. For this case, also the high pressure compressor to increase the pressure and also to increase the temperature. And then we feed to the extraction vessel. That's like extraction vessel. We have some carbon dioxide out. This collection vessel. This is some the beta carotene. That's like beta carotene, and the feed is from this feed to the system. So this is some example of the supercritical feed extraction system. And this is example of the extraction. This is for the aqueous phase extraction system. Aqueous phase extraction system, we choose the extraction to remove or recover the enzyme from bacterial cell suspension. For this case, we produce enzyme from the bacteria. Okay, after the fermentation, we have some cell suspension. That's like cell suspension from the growth. And then we use the beast meal mean the homogenizer or cell disruption. That's like cell disruption. And then we have heat exchanger. And also you feed to the mixer. We mix between the homogeneous. That's right. With the PEG and salt. This is for aqueous phase system. PEG, polyethylene glycol with water, and salt with water. That's like mix together and then send to the mixer with the homogeneous. That's like the extraction system. We have two systems, mixer and setter. Right. Mixer and setter. The setter for this case is cell division. Cell division means a very small particle of cell after disruption. That's like after disruption. And the solution sent to the second extractor. That's like second extractor. This is also salt feed to mix with the extract phase from the first extractor. Mix together. That's like mix together. Okay, and then we can separate the enzyme from the raffinate phase after the first. That's right. And then we will separate the enzyme and another like polyethylene glycol, PEG and salt. This is another example. Okay. And more detail for the extraction. That's right. More detail in the extraction. And the last topic that I did not show you in the slide is for example of the vibration technique. We call this the reciprocating plate extraction. For this case, we use the extraction and also we have the vibration technique. That's a vibration technique. Also, I talk to you how to scale up of the reciprocating plate extractor. You can read by yourself. I do not talk in the detail for that case. And I show you the technique to scale up, the technique to calculation and design of the vibration extractor in the lecture note. Okay, if you have a time, if you would like to read, please read by yourself. Okay, I will stop the